But I have some colleagues that will help me in that area. Any other question?
Doing chemistry.
Yeah, chemistry.
So it's very interesting with the course between soup and all that.
Yeah.
So just say, I mean, not just that you yourself are property that.
Yeah.
So that you're going to do yourself and you're going to study.
Yeah.
Right?
Yeah.
Materials and all.
Yeah. Thank you. Any other questions? No other questions? Thank you very much.
Thank you, Mr. Major, for your presentation. Well, for the past few hours, I guess I've been hearing about all the latest technology and the drones and so on, but it's a privilege to hear somebody having something to talk about sports. So once again, I thank you for that. Now, the next person for the presentation will be based on virtual reality, and his name is Mr. Rampersaud. Please give him a round of applause. Thank you.
Hi guys, my name is Rev Club. I'm a second year student at University of Guyana. Yeah, I'm studying computer science as my major, and what I'm going to do for you guys this afternoon is a presentation on virtual reality. Well, it's going to be brief, and what I'm going to be talking about is a brief history of what VR system was back then, and what it is now, and the fields that virtual reality are used in. So, how's that intro? So, what is virtual reality? Let's take the two words individually and define it. So, virtual means not real or fake, while reality means something that's realistic or existing in the real world. Now, what we can infer from this is that virtual reality is an artificial environment that can be interacted with on a seemingly real level or in a real way. Now, a more complex definition would be virtual reality is an artificial, computer-generated simulation or recreation of real-life environment or situation. It immerses the users by making them feel like they're experiencing the simulated reality firsthand, primarily by stimulating their vision and hearing. Now I'm going to mention some devices that we used in the past when virtual systems were coming into history. So this device is known as a stereoscope. And the way this works is you would use an image, two images are mounted to the front of the device, and you would look through it, through the lenses. It would portray this 3D effect through the lenses, which is now known as stereoscopic vision. And the two images would basically merge into one. As you look at it, it would merge into one, and you would get this 3D effect. So its first use was in the early 1800s. Now we have here another device that was developed in the 1950s by a man named Martin Hailey. And this is called the sensorama. Basically what this did was it used the same principle as the stereoscope above. There. So you would put your head into the machine and you will see the same 3D effects as what the stereoscope offered, but this device also had more features that would give you a virtual reality experience. Things such as cold air would be blown into your face, your body, whatever, and they had speakers to the sides of the machine. As you see, the guy's head is in there. Speakers would be at the side, and the chairs would be rocking back and forth. So if he's playing a game or a simulation of sorts, the interaction will be based on that game or simulation. Here we have two devices, two Nintendo devices that were used for VR. To the left is the Nintendo Virtual Boy, which uses the same stereoscopic vision. You use the controllers to navigate through a simulation or game. And to the right, we have Nintendo Power Glove. And you may be wondering, well, it's a glove. What exactly does it have to do with virtual reality? Well, what this glove does is it uses activation motion sensors, right? So you enter a sequence you enter a sequence and you move the gloves, you use the glove, so you move in any action, any direction or so, and it will be projected on screen. So a device a system that used this was the Nintendo Entertainment System that used this Nintendo Power Glove to stimulate games. Next here we have the Oculus Rift, and this is one of the popular VR headsets out there right now. This is a deconstructed diagram of it, so I'm just going to explain what each part does briefly. So we'll start with number one, which is up here, and that's the lenses. So what the lenses does is you look into it and you get this, you see the environment, the virtual environment through the display. And the display is here at number two. And what the display does is that it projects or portrays this virtual environment so that we can experience this 3D-like effect looking around. Next we have tracking technology. And well, what this does is, well, a bunch of sensors are placed into the Oculus Rift that keeps track of the position of our head. So while we're looking around, we're able to see like spaces all over, all around us. So that's what the tracking technology does. And 3D audio is not anywhere here, but it's a simulated program of sorts where two microphones are simulated to give you an effect of like you're actually in this environment and you're hearing what is being simulated inside this virtual environment. Virtual reality is used everywhere, and these are some of the fields that virtual reality is used in. So we have things like medicine, therapy, rehabilitation, entertainment, education, and the list goes on. A lot of you might know this device because this was taken at the Rev Club. It's a AirPod. It gives you a 9D experience and uses the Oculus headset. And I think the game that they use in this one is a roller coaster game. So what it does, you put on the VR headset, all right? You get a simulation that you're on a roller coaster, and what the AirPod does now is that it rocks you back and forth to give you the feeling that you're actually in or on a roller coaster and going up and down, traversing through the course. That is the Oculus headset piece there. I was actually lucky to get to see a guy that was playing, that was interacting with virtual space. And what this guy was doing, he was playing a game where he had to reattach some wires, probably for a spaceship or something. I didn't ask the game what was the objective of the game, apart from connecting wires. But it was cool the way he was doing it. He used controllers to interact with the virtual space, connecting wires, as you were seeing, as he had on the virtual headset. Now, this is another use in education we have here. Well, this is very wide because virtual reality can be used in all fields of study, practically all fields of study. We have fields in medicine, we have fields in surgery, even chemistry, astronomy. All of those fields can use virtual reality. And so to generalize it, it's fundamentally used to give better detail to different fields of study. So, for example, we have the field of surgery. There was a university, I don't know the country, but there was a university that surgeons implemented a virtual reality space that they could operate on people with precision. They would have everything laid out on this virtual reality where, say they want to dissect a heart, they want to reconnect tissues, they can do all of that using the virtual reality system. Virtual tourism, and this is a bit extreme of tourism because these people are on Mars. And what NASA did, right? NASA came up with a way to render images in order to create a full topography of the Mars landscape. And what they did is took all the images from the rovers, the satellites that they had floating around Mars, and they rendered it into a full landscape of Mars. So this is Bill and Katie on Mars next to the rover named Curiosity. Special needs cases, and this one is a very interesting story because this is a disabled boy that was playing the piano using just his eyes. And the way he did this was that a Japanese manufacturing company for VR headsets called Fold, they developed a software for VR headsets that allowed him to play the piano using his eyes. And what the technology did was it tracked the movements of his eyes using a bunch of different sensors, and how he played on it, it was, well, at the back here we have, these are the different keys, and they have different selections of if you wanted to play a single key, if you wanted to play an entire chord. So this is what it did. And the sequence activates by every time he blinks. So after the sensor picks up where he's looking at, he could just look into one of these circles and blink, and he could play the key on the piano, because the VR headset sends a signal to a host in the piano that presses the key for him. So how can VR technology benefit Guyana? You may be wondering that. I listed a bunch of reasons here. So it increases practicality in fields and opens areas for it. I'd say for the field of biology, when you want to dissect a frog or a heart to examine and look into in great detail. So you can do it as many times as you want, because I mean, it's kind of hard to keep getting a heart over and over and over if you want to, dissect and observe again. So, yeah. The immersive technology engages you more into a field of study. So instead of just having the theory of a field of study given to students, they can be engaged into the virtual reality of it and show more colorful, more living explanations of these concepts inside this field of study. So they will be more interested and more willing to engage in study. More stimulated and detailed explanations and illustrations for concepts. This is back to my two. More benefits include any special needs individual can be able to experience a little more of life than they went on with it. So for the disabled who are bedridden and they can't really walk around or go out much, they can be able to experience a little more life using these virtual reality systems. So for the virtual tourism, they can be able to, with good programming skills, with all the images rendered and the topography of the landscape setup, they can visit any country they want to from the comfort of their bed. That would help a lot to, help with the problem of depression. It's also used in construction projects and can be designed to produce an accurate layout routines. So instead of just having a normal 2D flat blueprint in front of you that you're going to work on, you can have a 3D concept of what you're going to be working on. Tourist attraction for people who want to immerse themselves into another location. Again, with good rendering and programming skills, you can be able to create these environments for, say, countries across the globe. Say China, you could visit China, you could visit Egypt, you could visit whatever country you want with the right programming and the rendering of images. And the list goes on. That's the end of my presentation. Any questions? Yes.
Thanks for the presentation. I just wanted, do you have any idea of costs for cameras and setting up?
No, honestly, I don't have any idea because I recently got into VRs, and Yeah. So
because one of the other fields is journalism. There's a field called immersive journalism. So it would be like recreating events, and go on, I think on ABC in America, they have some projects that they use so you can actually go back and experience events. I might have to teach you this part.
yeah, I've read about that in an article with an education section. They recreate these past events to give students a view of the history of what went on in the country. Yeah.
But I don't know, but I would love to know how much money, what is required to
Yeah, it's a great
Something.
yeah. Anyone else? Thank you for listening.
Thank you, Mr. Rampersaud, for your presentation. The next presentation will be based on big data, which will be presented by Mr. Andrew Garnett. Please give a round of applause, please.
Hi, good afternoon. I'm Andrew Garnett, second year computer science student, and I'll be talking about big data today. Okay, so big data it's pretty much as the name implies actually. It's large, like enormous amounts of unstructured data sets that can be processed by traditional databases. Like, I'm sure you all use Google search. That's a pretty prominent example. Like behind the scenes, you just type in a few words, and it's almost magical how they search and index like billions and billions of sites of information across the globe and give you exactly what you're looking for. Like I'm sure you don't even go to the second page of Google. You just type in the words you want, and if you don't get it, then you just change. And you only look at the first 5 options or so. Yeah. Okay, so there's like a jargon used to describe big data, like the 3 V's. There's volume, velocity, and variability. So I'll start with that. All right, so you can look at everything around us in this current age. You can see like smart watches, smart caps, smart shoes, smart shirts, everything. Every single basic item is becoming like smart. They're trying to add stuff. Cars can drive themselves, all kinds of stuff. Basically, you won't even have to think anymore, like 30 years ago. So, like, data is like a pretty important part of society now. Like in everything, it's required for you to have sensors and all these kinds of things to record and process data. Like, for example, in a single US flight, a single US flight has 240 terabytes of data. That's 240,000 gigabytes of data in a single US flight. And Facebook has approximately 900 million photos uploaded per day. Yeah. So, and velocity. Okay, so that refers to like the huge speeds that data will have to be transferred in big data. So, for example, the same Facebook, like thousands of photos per second that they will have to process and upload and then send back and do all kinds of stuff with the data, all in seconds. So, such technology is needed for that. Or using the same Facebook, there's click stream data. So sites they record where you click and ads for their own data taking. And when millions of people are doing that all at the same time, they need the infrastructure to take all of that and use it however they want. Finally, there's variety. So there are all these data types from geospatial data, which is like in Google Maps, that tells you where to go if if you need directions or whatever, to 3D, to audio and video, to even text without any structure, including log files. All these kinds of data that you have to store and manage in one, which is why big data is also needed. Traditional data sets are usually designed to handle consistent, predictable structures. So, what tech is used for big data? So we've now learned the reasons as to why traditional structures do not work in it. So the current best known example is a software known as Apache Hadoop, which was created by an engineer from Yahoo known as Doug Coffin. It was actually created as a counterweight to Google software known as Bigtable. So Hadoop attempts to break down big data problems into many small pieces that can be processed in parallel. So at the same time, it's broken down and processed. It's now open source and used successfully by many companies that handle their large data sets. It has two layers: the Hadoop Distributed File System, HDFS, and MapReduce. HDFS is a batch processing system. It does all the storing of the data in Hadoop. And it's separated into a name node and multiple data nodes. So all the data is sent across to the data nodes, and the name node contains the information on the data nodes in a simplified version. MapReduce is an implementation of an algorithm that was previously used in Google's solution to big data. It does all the processing of the data and has a resource manager and a node manager. Okay, so the importance of big data and how it can be used in Guyana. So I don't know how Guyana will be when I'm done my studies, but big data can be used in many ways. Like, for example, let's say at a hospital, you can track all these sicknesses and everything. Because the normal human eye, you can't really see the small trends and pick up any little patterns that can be useful in predicting a disease outbreak or predicting any such thing. You can't really pick out the small patterns. So that's why big data is useful for finding these small things. Or, for example, the finance of the country. You can work with the government and take all the stats and find these little patterns again that are invisible to the human eye and predict when the stock market might crash or the economy might fail and prevent lots of pain and suffering for people. So data is becoming a data-centric society, and big data has a huge role to play. So I'm pretty sure it's a reliable path to take if I want to help my country. That's it. Any questions? No, unfortunately not. Yeah. All right, that's it. Thanks.
Thank you, Mr. Garnett, for your presentation. Next up, we'll be having Mr. Roy Rampersaud. He'll be discussing on robotics tech in surgery. Please give him a round of applause, please. Thank you.
Good afternoon, everyone. I'll be doing a short PowerPoint presentation for my topic of the use of robotic technology in surgery. So how did I become interested in this particular field? It all began shortly after I enrolled in the University of Guyana, well, in the computer science program at the University of Guyana, where I discovered a new passion, which is the emerging technology of robotics. As a student, I became fascinated with robotic technology, and more specifically, its use in the field of medicine, particularly in surgical operations. The reason for my attraction to robotic technology is because I'm thinking of a career as a medical surgeon, and with the use of this technology, it is going to be quite exciting and will significantly improve the way surgeries are done in the near future. In Guyana, the idea of robotic technology is now coming to light with the recent formation of a robotics club. However, in the developed countries, robotic technology is a currently trending subset of computer science, and it continues to both progress and expand in the field of medical science.